Okay, look at example 7. Notice of subtract, and we got a subtraction symbol instead of an addition. It's the same process as addition. The only thing that the subtraction symbol does is we're going to be taking the top minus the top instead of the top plus the top. So there'll be some sign issues to deal with when we get to that point. The rest of the problem is the same as the others were. We have a denominator, x squared minus 6x minus 16, that does not match the other denominator, x squared plus 6x plus 8. So I want to factor them to begin with to see what the least common denominator of these two things is. So x squared minus 6x minus 16 is just a simple coefficient of 1 in front of x squared quadratic trinomial. So we need two numbers to multiply to make negative 16 and also add to make negative 6. What are those numbers?
Positive 2, negative 8.
Negative 8 times positive 2 makes negative 16. Negative 8 plus 2 makes negative 6. So again, just a quick check there. Pick two numbers, make sure they do what they're supposed to do. And again, it's because there's a 1 in front of the x squared that allows that to be the process. If there's a number in front of x squared that isn't 1, then we have to go through like we did in the last problem, where we have to do the whole factor by grouping thing. The other expression is x squared plus 6x plus 8. Now we need two numbers multiplied to make 8 that add to make 6. 4 and 2. Again, to do a quick check, 2 times 4 makes 8, 2 plus 4 makes 6, right? So that's my factored forms of each. So my least common multiple is every factor that occurs. So x minus 2 occurs, or sorry, x plus 2 occurs. X minus 8 occurs, and x plus 4 occurs. And it doesn't matter that x plus 2 happened multiple times. It happens, so it gets written down. If it happens, it matters. If it doesn't happen, it doesn't matter. Only write down what happened and only write it down once every time. Once you've written down everything that happens, the power of everything is 1, right? So it's just a bunch of 1s. So x plus 2, x minus 8, x plus 4 is the least common multiple. So I got my first fraction. And notice x plus 1 is more than one term. I don't know if I made a big deal about it in the first example, but it's more than one term. Put it in parentheses. On the bottom, x squared minus 6x minus 16 is this one, which is x plus 2 times x minus 8. And then we're subtracting the second fraction is also x plus 1 on top. And x squared plus 6x plus 8 are x plus 4 times x plus 2. We know what the least common multiple is supposed to be. We know what our current denominators are, so we need to do what's missing. So the first one, x plus 2 and x minus 8 are there. What's missing is x plus 4. And again, x plus 4 is being multiplied by the top, which is x plus 1, binomial times binomial. Make sure they're both in parentheses. It doesn't start off in parentheses in the problem. Usually needs to be put in parentheses when we get to the point where we're multiplying things. The second fraction, x plus 4 is already there, x plus 2 is already there, so x minus 8 is missing. Same deal, x plus 1 is on top in binomial form, so binomial structure, x minus 8. Now for the subtraction problems, my recommendation is this. Don't try putting them together until you get both tops simplified completely. Also within this step, if you want to simplify the denominators, make that simple, maybe I'd do that over here. So if I look at x plus 2 times x minus 8 is that expression. So this product makes that. So the least common multiple is x squared minus 6x minus 16 times x plus 4. X times everything gets me x cubed minus 6x squared minus 16x. Positive 4 times everything gets me 4x squared minus 24x minus 64. Combining like terms together, negative 6x squared, positive 4x squared, subtract to make negative 2x squared since the signs are different. Minus 16x minus 24x makes minus 40x, adding because the signs are the same, minus 64. That's what the bottom works out to. On top here, I've got binomial times binomial, which requires FOIL. So x times x is x squared. X times 4 is plus 4x. 1 times x is plus 1x. 1 times 4 is plus 4. The second fraction, again, it's subtracting, so I want to get everything simplified first before I start worrying about subtracting things. FOIL the top, x times x is x squared. X times negative 8 is negative 8x. 1 times x is positive 1x. 1 times negative 8 is negative 8. In each case, I'm putting the simplified denominator that we figured out over here on the bottom of each of these fractions. Can everybody see that 4x and 1x makes 5x here? Signs are the same, so plus 5x. Here the signs are different, so we subtract and get negative 7x. Okay. Here's the part that people tend to mess up on if they're not careful with the subtraction problems. I'm subtracting the numerator. I'm not subtracting the first piece of the numerator, I'm subtracting the entire numerator. So I'm subtracting each and every piece. So what I've got going on here, I've got my x squared plus 5x plus 4. It's kind of minding its own business. I'm subtracting x squared. I'm subtracting negative 7x, that's going to be plus 7x. And I'm subtracting negative 8, which is going to be plus 8. These signs need to be different because we're subtracting the entire numerator, not just the first part of it. That minus distributes through the top. The bottom stays x cubed minus 2x squared minus 40x minus 64. And then we just combine like terms on top. I've got x squared and negative x squared. I have positive 5x and positive 7x. I have positive 4 and positive 8. Again, it started off as a subtraction problem. At this point, I'm just combining like terms based on the signs I'm looking at. If the signs match, I add. If the signs are different, I subtract. Put the answer with the sign of a bigger number. For the x squareds, positive x squared, negative x squared cancel. They're opposites. They just go away completely. So x squared is just gone. 5x plus 7x both positive make positive 12x. 4 and 8 both positive make plus 12. All this is going to be over x cubed minus 2x squared minus 40x minus 64. That is the answer as far as we can go. As far as the domain is concerned, x cannot equal, if I go back to my factored form, the values of x that make 0 are going to be negative 2, positive 8, and negative 4. All right. Find a common denominator. Make the common denominator, make changes in numerators appropriate. Simplify the top completely, simplify the bottoms completely. Carry out the addition or subtraction of the numerators once they're in simplified form. Plus is pretty straightforward. Minus, be careful that minus sign distributes through. Get it completely simplified first before you distribute the minus sign. All right.